Hello, and welcome to my presentation on Can Use and Light Help Us in Space Travel. I chose this presentation because doing our science lab of shining a laser pointer through air, water, and glass, I thought, seeing the reflection and the refraction, what if we were able to translate this in space travel? Similar to the concept of using light to harness for human needs, using light in order to kill bugs and to get rid of pests, what if we were able to harness it in the form of travel? So I decided to do it on that. The article I found in my research is How Light Propulsion Works by Kevin Bonsor. In it, it explores the evolution of light travel, where it started off with the United States military with Project Star Wars in the 70s and 80s, where we planned on using lasers in order to track missiles and then shoot them down safely, now that we have them tracked with a laser weapon. Then eventually it got into the civilian market, where laser engines were developed, and now we are looking at the possibility of using laser engines in order to travel in space. Now, before we focus on light engines and can light help get us into space, we need to focus on, can we safely navigate in space? Because if you can't navigate in space, then traveling in space is pretty much an impossibility. Using the article Wavelengths from NASA Science, we do see that in space, objects all have a wavelength that they send out, but much is scattered. Infrared wavelengths are longer and are capable of passing through the infinite amount of space gas, dust, and rocks that are in the way. With that being said, though, infrared is not visible to the human eye as it is a longer wavelength than we are capable of seeing, meaning we need the aid of technology in order to see it, such as sensors and specialized equipment. Despite that, we are able to sense infrared light. Think of the sun. The light it gives us, that is the infrared light that we feel getting warm. Stuff that gives off infrared light are clouds of gas and dust, planets, cold stars, nebula, and more, such as a black hole. If we can't navigate, heck, you might get stuck in a black hole. Good luck getting out. Now that we've explored navigation, let's move on to using light to travel. Like everything with traveling, we use Newton's third law. Every action has an equal and opposite reaction. Using light to cause many small explosions helps propel the ships forward, and lasers are a cheaper alternative for space travel, as opposed to a large combustion engine requiring a lot of fuel, or a photon rocket. A photon rocket is a rocket that uses thrust from the momentum of emitted photon particles of light for its propulsion. Solar sails are another thing. Using reflective sails, light from the sun is trapped and used to propel a ship forward. For laser engines, while we are still some years away from laser engines for space travel, several successful tests have already been performed with light craft. This all coming from how light propulsion will work and how stuff works, as well as can we use powerful lights to propel spacecraft at the speed of light in the MIT Technology Review. Now, the forms of light power. Lasers. They heat up the air to the point that it explodes, generating thrust via Newton's third law. An explosion happens that sends us forward because the light is constantly going out, pushing us further away. The other alternative is beam power, where it generates power through the use of lasers and transmits it to the craft. The US Navy has actually successfully used beam power to transmit energy from space to Earth to be used by stuff on Earth. From how light propulsion will work, how stuff works, as well as US Navy successfully beams power from space to Earth in strange sounds. Knowing that beam power is possible, we could, in theory, create an engineering plant using lasers to generate the power and then transmit it up to a spacecraft, enabling it to go into space, get a refuel, and then go off further places. Components of laser engines. For the component of a laser engine, you have four primary parts. The first is a carbon dioxide laser. It heats up the air around it to cause numerous tiny explosions to propel the shuttle forward, again via Newton's third law of motion. Next up, you have a parabolic mirror. The first part is going to focus the laser into the engine or propellant for just the engine. Now I say that because the current solution for space travel, according to how light propulsion will work and how stuff works, is another laser will be placed on the ground shooting at a secondary parabolic mirror on the space shuttle, enabling it to take off from our atmosphere with very little stuff. Next is the absorption chamber. The air is directed into the chamber where it gets heated, expands, and propels the craft forward. And finally, an onboard hydrogen chamber, where a small amount of hydrogen propellant is used for thrust when the atmosphere is too thin to provide enough air. If we land on an asteroid or Pluto, we wouldn't really be able to do anything with it, so we would need help in getting up. Is photon travel possible technologically? At the moment, no. Photon rockets are impractical because of the size and current designs. Finding antimatter is considered essential for photon rockets, and the reaction it would cause is just as likely to cause the ship to explode as it is to send you forward. Despite that, solar sails have shown that light can be used to travel. The issue with solar sails, though, is they require something from the sun or another star. We are too far away from another star for it to be practical to use a solar sail, and getting too far away from our sun means you're no longer going to be able to travel at a certain speed or slow down until you reach another star. So unless you're able to get up to this required speed before you exit the sun's ability with infrared power, you're not going to be able to travel all that fast. New changes and development. Unfortunately for all the new changes, development, and policy, it is going against space travel at the moment. According to NASA, budget woes put ambitious space research at risk from ScienceNews.org, and final NASA 2024 spending bill defers decision on MSR funding from Space News. Congress has cut funding for NASA for the current year in their spending bill. Again, current plans for Mars have most of the NASA budget, but are struggling to find ways to make up the cuts, as just getting to Mars is an expensive endeavor. Focus for government currently has shifted away from space exploration to more practical stuff, such as military spending on Earth, economy, healthcare, and stuff like that. So at the moment, with the new changes and development, it's making space travel look like a bigger impossibility. Is it possible to use light in space? Yes, but only in the local galactic neighborhood. Since space is so large that technology is not yet at the point where we can travel outside of it, we are limited to the local galaxy cluster, well, solar system cluster to be exact. While in the future it is considered likely that we can travel outside of our solar system. With that being said, I now have a new question. Is using laser as a form of power a practical solution in mankind's pursuit of interstellar space travel?